In this video, I'm going to solve a problem on simple stress. Here's the problem. Determine the maximum vertical force P that can be applied to the bell crank so that the average normal stress developed in the 10 millimeter diameter rod CD and the average shear stress developed in the 6 millimeter diameter double sheared pin B not exceed 175 megapascal and 75 megapascal respectively. So what we are going to do here is we will solve for the force in rod CD in terms of P as well as solve for the reaction at P in terms of P. And then after that, i-test na to using the criteria or the condition given for normal stress of rod CD as well as the shear stress of the pin at P. So we will cut rod CD and then we will put the force. Okay, so it's force or tension CD. And then for B, since the support is a pin, so we have two reaction components. You have RBY and also the horizontal component RBX. Okay, so there are three equilibrium conditions. So mention of force along the horizontal equal to zero, force along the vertical equal to zero, and summation of moment about a particular point equal to zero. And we also have three unknowns. So let's first sum up moment about V so that we can solve for FCD. But we need the perpendicular distance of FCD to B. Okay. So the distance from B to C is given as well as the angle 45. So the perpendicular distance of FCD to B is 300 sine 45 degrees. Okay. So first, let us sum up moment about V. And counterclockwise moment as positive. So the moment of FCD is counterclockwise while ang sa P is clockwise. So we have FCD times distance 300 sine 45 minus P times distance 450. So solving for FCD, we transpose P, this term to the right. So we have FCD equals 450P over 300 sine 45 degrees. So using your calculator, let's divide 450 divided by 300 sine 45. The answer is 2.121 P. So 2.121 P. Okay. Next is we will sum up force along the horizontal and force to the right denoted as positive. So RBX is positive while FCD is negative since it is directed to the left. We have RBX minus FCD or our FCD is 2.121 P. So RBX is equal to 2.121 P. Okay. And then summation of force along the vertical to solve for RBY. Upward force positive. So we have RBY and minus P. The other vertical force. So RBY is equal to P. After this, we will solve for the resultant or the reaction at B. So solving for RB. So RB is square root of RBX squared plus RBY squared, or substitute, that's 2.121 P, sorry, 2.121 P squared plus P squared, and we have this one, square root of 2.121 squared plus 1 squared. The answer is 2.345. 2.345 P. Now, since we now have the force of CD and the reaction at B in terms of P, we can now solve for P. Let's use the given condition. The stress of CD must not exceed 175 megapascal. So for rod CD, okay, we have 175 megapascal as a unit of Newton per millimeter square. So it's Newton per millimeter square. And force of CD is 2.121 E. And for the area, circular with diameter equal to 10. So it's pi over 4, 10 millimeters squared. So we have the first value of P based sa condition na 175 megapascal. You can use shift solve, or you can just cross multiply 175 times pi over 4 times 10 squared divided by 2.121. The result is 6,480.18 newtons. And for the other criteria is for the pin at B. The shear stress at B, or the shear stress of the pin at B, must not exceed 75 megapascal. So let's have this one, pin at B. So we have 75, same unit, Newton per millimeter square, and the force is the resultant here, 2.345 P. And for the area, it's given in the problem now, double shear and pin. So let's multiply the area by 2. And circular, diameter of 6. You have pi over 4, 6 millimeters square. So, okay. Let's cross multiply 75 times 2 times pi over 4 times 6 squared divided by 2.345. The answer is 1,808. It's 1,808.6. Okay, now we have two values of P, and if you want to determine the largest, it should be the smaller value para safe. Okay, because if you will use 6,480 on this equation, okay, if you replace P by this value, the average the shear stress of the pin will exceed 75 megapascal. So mag-fail ang pin. But if you will use 1,808.6 Newton sa equation sa rod CD, the normal stress of rod CD is less than 175. So safe siya. So therefore, the largest value of P is 1,808.6 newtons. Or if you want to convert your answer to kilonewton, then the value of P is 1.81 kilo Newton. Okay. That's it. I hope that you have learned something from this video. And thanks for watching.